Alright, so I did a stream earlier on L Systems, which was really cool, and I recorded the whole thing, and I didn't record my voice over any of it. So it's just 2 hours of silence, and that is not very useful. So I'm just going to go through what we talked about, the basic meat of what we talked about. Again here, and just post it to YouTube, and we'll go from there. So the first thing I started with was so a couple slides, because I wanted to tell people what this was about, and namely that this is about converting these things called EisenScripts that are used by like a fractal generating program called Structure Synth into something that Blender and Sverchok can use. So these scripts are, so we're going to convert these scripts to XML, which is what the Sverchok Generative Node uses. And then we'll talk about how to use them. We'll play around with the results in Sverchok as well a little bit. This is not how to make a shape, how to turn a shape into a rule set. That is like the big question, is how do you make the rule set do what you want? And I don't know. I don't know anybody who does. This is the deal. I'm just putting this slide up because it's funny or whatever. But the one thing that I'm hoping for is that the whole deal with this is like learning by example, and so I'm going to point to examples, and by toying around with various examples, then maybe we can figure things out. And we, I mean everybody else. So the first thing we looked at was the XML rule set structure. This is an annotated version that I wrote up. And the idea behind this was like, I'm not trying to deliver all this information in just this one video. This is supposed to be a rubric to go through when you're converting a rule, so you can refer to this to help you convert it. But basically, it's like, it's just this, there's the main rules thing that encloses the whole thing. And there's each of these rules, and in these rules there are what's called statements, and each statement and rule and so on has various arguments like max depth and weight and successor. They point to some other rule. You can instance a shape. So thinking about kind of conceptually what these pieces are is like, rules are kind of like destinations, and the statements in them are kind of telling things where to go. But that's a very vague way of saying it. There's just a couple other things about them. Is like, there has to be an entry rule, which is where the whole thing starts off. Degenerate rules are rules that have the same name, and the interpreter, the generative node interpreter, will call those in a semi-random fashion. And when I say semi-random, is you can use this weight parameter to adjust how often those are called. So if, say, this one is weight 1 and this one is weight 2, this rule with the same name will be called twice as often. And other than that, it's just like a lot of variety. It's just toying around with options and statements and so on. And there's any number as far as I know. And this is just kind of to visually show what the rules look like, so you know what you should be looking at, just to kind of internalize the structure. So what we're doing, the whole deal here is that we're taking these EisenScripts and we're turning them into the XMLs that the generative node can use. So this is just one put up. It's just an example one. And again, this is the same deal. I'm just putting this up here to show what the structure of one of these looks like. And obviously it's like completely different, but it turns out that almost all of the pieces in here have a sort of conversion, a direct conversion to the what the rules the generative node takes in. So this same thing, this is supposed to be a reference. This is pointing to each part of the EisenScript and saying this is what it turns into for the XML. So like set max depth is the main rules header max depth, and then this block here that's not enclosed in anything is the entry rule, and you can see that R1 turns into call rule R1, and 36 times this statement turns into call count 36 transforms tx minus 2 ry10 rule R1. You have these successor rules, which instead of using this caret symbol, it's just you write in successor equals the successor rule name. We'll get to what successors are later, but the only other thing, the one thing to note is there's these like B and H and A values, or hue or saturation. Those are color information for structure synth. I ignore them. I mean, the whole point here is that we're putting this into Blender so that we can really use what we're creating, and we don't need to specify the colors and stuff beforehand. We're going to do that later. So all we're looking for is the shape. And then the one thing that I think I've struggled with in terms of converting is these count operations. So if you have one step of like 36 times this operation in a rule, it directly converts over to a call count of 36, blah blah blah. If you have two, like this one, 2 times this, 3 times that, you can't have two count operations in the same statement, and I don't know how to deal with that. So that's an open question. So again, reference information here. You can look at the actual web page for Structure Synth. They talk about all the pieces, and it's kind of nice. It's a little bit interactive. So that's another reference, and then of course, like you can look at what Sverchok has to say. If I can actually, whatever. This is just a link to the generative node. They're kind of, the information they give you is always kind of scant, and it's not what you're looking for. It's not like here's how to make the shape. It's just like here's what the pieces mean. So at this point, what we did is I went and I picked a rule and I converted it, and hilariously I picked a rule somehow and converted it, and it didn't work. And I have like this, like something like 8 out of 10 or 9 out of 10 times I'll convert a rule from an EisenScript to XML, and it'll work. And of course, for the stream, I chose one that doesn't work. I'm not going to do that this time. I'm going to actually choose one that I know works. But first, I want to go over to here, which is like this guy, Anchor Pawar. He has this whole web page of Structure Synth examples, and in particular, he has a GitHub with all the rule sets. So even beyond his web page, he's got all these rule sets, and it's just like, I mean, it's so awesome. And he's got, and so this is what I've been using mainly. I just go here and I pick one and I try to convert it. So that's what I did on the stream. It didn't work, but I'm going to pick up a specific one that we're going to be working with anyway, and it's this. So let's take this text here and let's go ahead and convert it to an actual rule. So let me set up my editor here for a second. So I'm going to copy an older rule just so I have the structure. And let's start taking a look at this. So this is kind of interesting. So this is a constant, this defined gap. I think I have to look again the way you do that. Yeah, you can do a constant line in here, so in the XML version, so we'll do that. So this is exactly the same thing as what this define statement does. And then we've got the set max depth 200, so that's our main max depth. Set background white, color info, we don't care. Set color pool, we don't care. Tree, okay, that is the entry rule. It's saying call rule tree. Now rule tree and MD6. Means the MD. I'm pretty sure means max depth. So this is the actual tree rule. So let's start putting that together. So rule name tree, max depth 6 doesn't have a successor, so we'll ignore that. So call. So this is saying move in the x direction, length gap, scale in all axes 0.49. Okay, so I'm gonna have to look up syntax for this in a second, but we'll start this out. So it's something like, so tx is move in the x direction for the XML rule, and then I think it's something like putting in curly brackets references the constant. I'll double check that in a second. And then SA 0.49. So Sverchok, or the XML has two versions of the scale. So you can do S like 1, 2, 3, and that'll scale the x-axis 1, the y-axis 2, the z-axis 3, or you can do SA whatever, and that'll just scale all of them by the same amount. And it's just that's one place where they're slightly different. So this is a bunch of copies, really, of the same rule. So let's copy this. Actually, before we do that, let's go ahead and look up our syntax. So we'll go to Sverchok Generative Node. And somewhere down here, they talk about constants. Yeah, okay, so I think it is just in, it looks like it is just in curly brackets, but it does something really cool, which I will show you, which somebody graciously from the stream messaged me after they discovered it. So I think we're okay on our syntax. So let's say we've got tx gap, ty0, sa 0.49. Now we have rz 90, which is rotate about the z-axis 90 degrees. Call rule tree. Copy this again. Tx gap, ty0, sa 0.49, rz minus 90. Okay. Now we've got tx gap. Which one am I on? So we just did this one. Just did that one. What's the distinction here? Looks like the same rule to me. Okay. We'll see if it actually is. Dx gap, ty0, s 8.49, ry 90. So let's just double check that. This is what it is. This is an ry. RZ, RZ, RY, RY, and all TX. And then saying call rule. This here is just saying call rule plus. So let's see rule plus. Okay, simple rule. doesn't have a max depth, doesn't have a successor. TX 0.25, SA 0.2. So this is actually scaling it differently on each axis. So this is now S 0.2511. And then we have our Z90. Call rule E. So what this rule is saying is put, like this particular rule D is saying place a box. And instead of doing that, which doesn't really translate well into the generative node, because it doesn't, the generative, you're supposed to be able to generate shapes or something with the generative node. I haven't quite figured it out. What works best for me is whenever, like literally whenever they make a instance of shape in the EisenScript rule, like box, sphere, triangle, whatever, I always just do a vertex because it's gonna put the matrix, the orientation matrix there, and that's what I want. Maybe there's something I'm missing, but I don't know. So the only difference really is that instead of call, it becomes instance, and transforms are, looks like it's an S 0.05 to 0.05. Color, we don't care. And what you do is just say instead of rule, you say shape vertex. Okay. So we should be done with this rule. I suspect, because this always happens, there's some minor syntax error in here. Like for example, this is supposed to be a tree, not an R1. But I almost never get these right on the first try. So let's go into Blender and see what we get anyways. This is the whole default scene. And there it is. So now what we're going to do is we're going to pull in a generative node. And I think those are in like art or script or something. Okay, so here it is, the generative node. I'm going to set these maps down because that can crash things. All right, let's open it. Amazing. This will, if you load it and it doesn't, if it just stays blank, there's no syntax errors, so it's as it stands an evaluable rule. So let's actually see what this looks like. So is it doing anything like what we want? Yes, it is. It is doing exactly what we want. Okay, cool. So I'm going to put in a very, very amazing trick here. So what I'm going to do is, what's going on here is that it's putting a matrix on like each segment of this tree. So we can sort of start to see, if I can find it again. Where did it go? There. Okay, so we can sort of start to see already that we've got that structure. And if we bump up the matrices to like, you know, it's clearly getting there. Drawing matrices doesn't make Blender or Sverchok or something happy, so it's better to instance something on them. But at any rate, along each of these segments of the tree, it's making a matrix, which we can use for instancing purposes. And what's really amazing is that if we put a line on them, if we instance a line on those matrices, and so this, think of this vertex output as the matrix, then it will put those lines on the matrices, and this isn't going to look great at first, but it will get there. So it is doing something. The issue really is that our lines are not the right scale, and they also aren't oriented right. There we go. So you just have to toy with this, because there's no guarantees about orientation of anything, not to mention, as you've probably noticed, this is along the wrong axis. So it's growing kind of along the x direction. You can go into the rules and get this to grow like along the z-axis by changing, which direction it's doing things in. It works with this one. You have to change the x to a z, and then when you do that, you have to change x to z everywhere. So, for example, in this scale operation here, you have to swap the z scale with the x scale, and then vice versa. So this z becomes an x, and so on. Somewhat easier method, really, because sometimes this doesn't even work, is just to get us another matrix apply here and take our whole thing. So this is like our tree now, right? Because we've got a tree of lines, and so we really want to think of this as what the tree is or whatever. Well, it might work on this too, but actually, you know what? That's probably the better way to do it. So let me do it that way. Matrix path. So the better way is to just adjust the generative node output matrix, and then call this thing like that's our tree. Like don't worry about anything else and just take from there. So what we want to do is, I think it's a -90. Okay, so no, it's not. Oh, it's probably because of that. Okay, no. So it's a y rotation. It's a -90 y rotation. Okay, there we go. All right, we got our tree. It's up, and we've got a whole nice structure made from lines. That's cool, I guess. I mean, I think it is cool, but we can also do another quick thing right now, which is put, say, a cylinder on it. So instead of lines, I'm going to drop, just again, this is due to, I'm trying to avoid crashes here, so I'm just going to do that. So instead of a line, let's put a cylinder on this. And it looks super, like, not anything. But we're going to fix that. So this time, we're going to take a matrix apply and put it in between here. And we're going to use that matrix apply. This is the one I think that's actually supposed to be a -90. Yeah, okay. So now we've got the cylinders going more kind of in the way we want them to. And once again, if we set the height to 1, it makes more sense because now it's sort of like operating in the scale that the node thinks it is in. So I'm going to set this down because we don't really need it to be so many. And then we can just bump this back up. And we've got a solid tree. And we can do cooler stuff like taper the top. That's the bottom because things are flipped around. So now it's like sort of more branch-like. So anyway, this is a actually cleaner version, I think, of what we talked about in the stream. We went further than this. I'm going to pause now and continue what we talked about tomorrow and upload this now maybe or something. I don't know. We'll see how it looks. But anyway, thank you for watching. I'm not a professional streamer, so bear with me.